Hi everyone, Krishna this side. So in this video, I'll be covering this lead code problem 1922, count good numbers. So if we have solved the morning's lead code problem, this is going to be the easy problem compared with that one. And this is also medium level problem, but yes, any hard level problem that we solve, it basically covers most of the similar medium level questions which falls under different categories because hard level problem basically combines different concepts and we have to solve that one. So yes, if you have solved that hard level problem, this is going to be pretty much easy for us. So yes, to just cover this for this day, because it basically falls under the similar category, but it is actually pretty much easy compared with the morning's problem. Okay, because yes, it is a medium level problem, but still it will look very easy if you have solved that morning's problem. Okay, so let us look into the problem statement. If you want to solve this one, still not it attempted, you can solve this one. So yes, let us look into the problem statement first and we will discuss about the logic and I'll write down the code as well. Okay. So a digit string is good if digits 0 index at even indices are even and digits at odd indices are prime numbers such that like 2, 3, 5 or 7. Okay, for example 2582 is a good because digits 2 and 8. Okay, 2 and 8 at even positions. See, these are basically started with the 0 index, so the 0th index is basically even, and the second index is also even, which is having value 8. At even positions are even, and the digits at 5 and 2 both are at odd positions. Okay, and they are prime numbers. However, this whatever this example 3, 2, 4, 5 is not a good because 3 is at even index. So whatever the three value that we have at 0th index, it is actually the even index, but value is actually prime, or we can say it is odd. So it is not a actually the good numbers. Okay. So given an integer n, return the total number of good digit strings of length n. Since the answer may be large, return the modulo of 10 to the power of 9 plus 7. Digit string is a string consists of digit 0 through 9 that may contains leading zeros. Okay, so whatever the digit that we are the string that we are forming, it will contain 0 or 0 till 9, all these digits. Okay, it can contain leading zeros as well. Okay, so now n is actually equals to 1. So we have given this n length. So in this n, how many digits that we can put, right? So if let us suppose if n is actually equals to 1, so at this 0th place, okay, it is even location, right? We can keep all the even numbers. What are they? 0, 2, 4, 6 or 8. Okay, at this location. So how many strings that we can form? It is like 5 strings we can form, right? So it is like even it is mentioned that the good numbers of the length 1 are 0, 2, 4, 6, 8. So what if the length of this n is actually equals to 2? Okay, at 0th location we can have these many possibilities. Okay, these many characters we can place at 0th location, or the digits we can place at first location. Okay, at 0th location we place all these one. Okay, at 0th one we placed. Now the length of this string is basically equals to 2. So yes, at first location we have to put all the odd numbers. Okay, prime numbers. So how many prime numbers we can pick from 0, 3, 9, 3 till 9? They are basically 2, 3, 5 and 7. Correct. These are the prime numbers we can put. So how many combinations we can have here? They are in total 5 combinations we can have. Here they are in total like 4 possibilities that we have. So in total it is like 5 into 4. So yes, 20 possibilities we can get it. Okay, 20 different strings we can create from this one. Okay, so yes, that's how we are actually picking this one. Okay, so 0, 2, 0, 3, 0, 5, 0, 7, one possibility, then it is 2, 2, 2, 3, 2, 5, 2, 7, then it is 4, 2, 4, 3, so on, like till 8 we will be having different possibilities. So yes, we are pretty much clear that whatever the even index that we are having at the even index, we can have 5 possibilities. At odd index we will be having 4 possibilities. So yes, it is clear that now even indexes are like how 5 possibilities we will be having, odd indices will be having 4 possibilities. So if n is actually equals to 4, at 0th index 5 possibilities will be there, at first index 4 possibilities will be there, again at second index 5 possibilities, and at third index 4 possibilities. In total it is like of length 4. Okay, starting from 0. So yes, this can be represented as like 5 into 4 into 5 into 4. In total, we can get the answer. Okay. So yes, we are clear that whatever the n value that we got, we can keep on checking if whatever the index that we are at, if it is odd or even, and we can keep on multiplying with respective values. Okay. Either with 5 or 4. So for 50, it is the same. But the problem is with the constraint. Okay. If we try to solve this particular problem in big O of n, the constraint says that the n value can be go up to 10 to the power of 15. Okay. And this is actually a really big number. Okay. So, and it is going beyond 10 to the power of 6. Okay. So we cannot even consider big O of n solution for this particular problem, and we have to think about logarithmic of solution. Okay, how we can convert the whatever the solution that we are trying to get, either it should be constant or till log n we have to get the solution. Okay, so yes, at different location we have different values. Okay, and this entire representation, okay, if n equals to 4, this entire representation we can represent it into like 5 into 4 is basically 20, 5 into 4 is basically 20, 20 is actually appeared two times, correct? That is how it is appearing. So 5 into 4 is 20, again this 5 into 4 is 20, so 20 into 20 is basically 20 to the power of 2. Okay, and this is how we can represent this one, correct? This is the clarity that we got. Okay, 20 to the power of 2 also we can represent these values. So basically it is like 20 to the power of n divided by 2. That is how we are doing it, right? If n is actually equals to 5, this is how the numbers basically get represented: 5 into 4 into 5 into 4 into 5. So basically extra 5 is something what we get outside, and 20 to the power of 2, again 5 divided by 2. Okay, that is how we can represent it. So now the idea is clear. If let us suppose n is actually equals to 101, so what we can do is 5 into 20 to the power of 20 to the power of this 100 divided 101 divided by 2 is basically 50. So this, if we solve this, we can get the answer. Okay, the idea is pretty much clear now. If it was 100, okay, if n is actually equals to 100, this 5 is something we can remove it. Okay, so yes, based on number, if it is even, we can simply get 20 to the power of half of this number. If it is odd, 5 into whatever this 20 to the power of 50, that is the answer that we have to get it. Okay, this way, since this power of any number, we can solve it in log of n. Okay, logarithm in the log, we can solve this one. Okay, that is something we have already in the solution. In the morning also, whatever the problem that we solved, we have solved with the help of this logarithmic time only. Okay, so yes, that way we can solve it. So this particular whatever the solution that we are looking at, this will be getting solved in log n time, and the complexity get reduced from big O of n to big O of log n. So yes, the idea is pretty much clear now. Let us try to solve this code, and we will first, what we'll do is we will create a result. Okay, we will check that if this n, whatever the n that we have, if this n is actually even or odd. So to check that, we can either put modulo, or we can do this n and 1. That is something I already explained also in previous videos. So whatever the n value at 0, the rightmost element, whatever we have, that if it is actually 1 in the binary representation, of course that number is going to be odd. So if this AND operation with 1, if it is giving 1, so it is basically going to be odd number. So if odd number is there, what we are doing, we are basically multiplying that value with the 5, and we are getting this power of this number. Okay, so yes, that is something what we do. 5 is something what we will store initially. If it is even number, we will store 1 in the result, and this result is something what we will return. Okay, so return, since it is asking into the int. Okay, so I'll make sure this I'll convert it into the end, and I'll return this result. Now we have something. Now what we can do is we will divide this n. So n divided by 2 is something what we can do it, or else even left shift operator is something what we use to divide that number. N is something got divided. So now if it was 101 or 100, it will get divided, and n value is something what we got. Whatever the n value that we are looking, the power value, okay, exponential value, that is something what we got. And also the base is something what we have to define. So base is basically equals to 20. Okay, this derivation we already figured out from this one. So 20 is the value that we can get it, keep on getting these values, and that is something what we already figured out. And the exponential values also we got, that is actually equals to n, or we can name it as exponential, but let it be right now. N is actually equals to left shift of 1. Now both the values we got. The basic thing to get power of any number in a log ways, what we can do, this n should be actually greater than 0. Okay, that is the base condition. And first thing we check is if this n, whatever the n that we got, if it is actually even or odd. So yes, how we can check? Again, the same thing we can apply. Whatever this previously we have written, I'll just copy paste right over here. So if that is the case, so what we can do is the result what we have. In this result, we will simply multiply it with base. So let us say that n is actually equals to 3. Okay, n is actually equals to 3. So it is actually odd. So currently result is actually holding 5 into that, and 20 to the power of 1 is basically it will be having, because n again we are shifting it to left shifting to 1 bit, so it is basically n divided by 3, so n divided by 2. So 3 was there, so 3 divided by 2 is basically 1. So again we will enter into this directly if condition, and base is 20, so 20 into whatever the answer that we have, result we have 5, is something what we will multiply. Okay, that was the pretty much clear idea. So let us put mod as well, because the answer could be big and we already have to write the answer into the module. So at any time point in time, whenever we perform any operations, we will put the modulo operation. Okay, now this is done. We will update the base equals to base into base. That is how we solve this type of questions, and we will apply the mod. Now base is also got updated, so again we will divide this n in, with 1, n with 2. Okay, I am just shifting the bit. Okay, the moment we shift this bit, it is actually I mean for 3, we will try to get the answer. Okay, let us say that if n is actually equals to 1. Okay, if n is actually equals to 1, so how the result works? So result is actually we are checking that if n is actually odd or even, so it is odd, so result 5 is something what we got. Okay, now n is actually what we are doing, we are dividing it with 2. So 1 divided by 2 is basically 0. Okay, now n is actually 0 and the base value is 20. So we enter in this, we check that if n is actually equals to, greater than 0 or not. So n value is actually equals to 0. So we do not enter into this value, and the result is what we are returning at the end. Okay, we are converted into n and we are returning it. Now if what if n is actually equals to 2? So when n is actually equals to 2, we check that if it is odd or even it is even, so result is actually 1 by default. When we do that, when we do this operation n equals to n left shift of 1, it is going to be 1. Okay, 2 divided by 2 is basically 1. So 1 is something what we got updated here. Now base is 20, we enter into this one because n is actually greater than 0. We check that if n is odd, so yes, n is actually odd now, so we enter into this condition, so result is actually equals to result into 20. So new result is actually 20. 20 is something what we got, and base value will get updated, n gets shifted, so 1 left shift of 1 is basically equals to 0. So yes, we come out of this loop and we return the result. So for n equals to 20, the result is actually 20. Okay, that is something what we saw also. For 3 also the same thing happens, and this will keep on going. So that way we can get the answer. Okay, so yes, it is pretty much straightforward. If we have solved a morning problem, it can be easily done. Let us run this code, and let's see if we are having any issues. No, all tests are getting passed, and yes, it is actually happening in log of n time, this particular while loop, because whatever the answer that we are getting, we are keep on if by default base is 20, so it is going to be 400 for the next time, 400 into 400. That's how, like in exponential, we are keep on multiplying the values and dividing this n until and unless n is actually equals to 1. So once we get the result, we will be updating the result, and we will be come out of this loop. Okay, the moment we get n equals to 1, it will left shift and we get out of this loop. So that way we can solve this particular problem. Let me submit this one, and yes, the time complexity is again it's going to be log of n. We are not storing any space. So yes, that is all about this particular video. Thank you for watching this one. Bye bye.